list. If you print your email on that list, I'll add you to our distribution list. But print neatly so I can read it, because that is a problem. Also, if you're a member of AFC, current membership is good and everything, and you want a name tag, there's another sheet over there. Again, print neatly, or you'll get a name tag with the wrong name on it. But I'll make up some name tags. Iron in the Hat table is back in the back, and I'll sell tickets to that. So if you want to get involved with that, let me know. If you got any other issues, I don't do the AFC memberships. I'm just the secretary treasurer for this forge. So I handle our money and meeting emails and stuff. So I will send one out saying no meeting, but I'll send it out closer to the no meeting. So I think that's about all I've got for now.
Yeah, you might make mention of our new grinder.
Oh, yeah.
We bought with some of our Iron in the Hat money.
Yeah, our forge group bought this Ameriblade grinder back here on the table. And they make a quality grinder. It's made here in America. Our forge group had sales and had a little money in the bank, so we bought a grinder for the forge group. It's a handy tool to have. We're glad to have it. Y'all go back there and check it out. And
Calvin, what kind of money is that?
that grinder back there is the basic package. It's got the single speed motor. It's got a 6-inch wheel and a flat plate and steady rest. And it's going for $1,300, and that was switched to our door.
Yeah, that's a good price.
So,
and I brought mine for show and tell over here on the other table.
and speaking of show and tell,
Yeah, so this table over here, the stuff on the far end, that other half is mine, stuff that I've made. And then the end over here, the end closest to me, that half of the table has most of the stuff on it. That is all antique stuff. And some of that I'll talk about. Just feel free to ask questions about anything there.
So I'm gonna turn it over to Jordan.
All right. So first of all, I want to thank y'all for having me down here, Calvin for making it happen, and I want to give some caveats. First of all, I've only been blacksmithing for about 5-6 years now. I've been full time for 2 years, work at home. And my primary area of interest is like early American work. I do most of my work with hand tools. I don't have a power hammer yet. Been putting that off as long as possible. I need glasses real bad, and I'm only familiar with my forge at home. So that's, if I screw up, I'm gonna blame it on one of those two things or somebody else. And let's see, there was something else, and I don't remember what it was. But y'all feel free to. I'm going to try to move along as quick as I can. I did this hinge at home. It took me about 2 hours. I'm hoping we can wrap it up around lunchtime. But y'all just tell me if you want to go longer to finish up. That's fine. But please feel free to throw any questions at me you want, and see what we can get done. I'm going to be using wrought iron, just because I want to. So I've got this piece here for my strap, and I've already made up some 3/8 round pencil pins, and then I've made up a bar that I'm going to make the pencil out of. So we're making a basic strap with a forge welded eye and a basic drive pencil that's also forge welded. So any questions? And we can pass this around if anybody wants to look at it going into it.
You actually ridged the pin too.
Yeah, that's real typical to see on the drive pencils. See them barbed. You can't really drive them straight into a piece of wood without splitting the wood. Let me grab a couple of these. So that's a really small pencil. That would be appropriate for a shutter or something like that. But pencils come in all sizes. And there are lots of other kinds of pencils besides drive pencils. But check that one out. That'd be like for a big gate or barn door hinge. So, and then there's a couple in between sizes. And but yeah, it's real typical to see them barbed It just helps keep them from ever loosening in the hole coming out. But typical installation is you either drill a stepped hole to account for the taper, and pre-drill a stepped hole in the wood, or it was also fairly common back in the day to heat the pintle up in a small forge and pre-drill a hole a certain size and then run the red hot pintle into the hole, not all the way, but to burn the hole out close to size. So I've been doing a lot of work in wrought iron, mostly for myself lately. I'm still building my shop 2 years after going full time. The wind is howling through it, rain's blowing in, all that stuff, good stuff. But I find my wrought iron wherever, scrap, wagon tire, buggy tire, whatever I can get my hands on. And I'm convinced that a lot of the wrought iron that you can easily find is the lower grade stuff compared to, historically. Wagon tire definitely tends to be lower grade wrought iron. But I've found generally that I can still work with it. But you do want to do most of your forging at a real high heat, a welding heat, at least until you welded up any cracks and kind of consolidated it and whatnot. But you may see me you'll probably see me make the mistake of working in too cold today, and I'll crack something. It's just borax, and I won't flux the bar as I work it down. But yeah, I'm no expert on forge welding, but I am a big believer in flux. Maybe someday I'll get to where I know how to work the fire, so I don't have to use flux. But flux seems like there's a lot of debate, so I'm just going to throw my 2 cents in. But flux, all it really does is prevent oxidization on the surface of the hot metal, and that's my opinion. But the advantage to that is for conditions to be right. Let's get it nice and hot. For conditions to be right for the weld, not only does the metal have to be hot, but if the surface is too oxidized, it's not going to stick good. So that's where the flux comes in handy. And I actually, if you understand it that way, if you understand flux to be something that prevents oxidization, I'll actually use the flux, like if I'm welding a hinge eye or something like that, I'll generally cover not always, but sometimes I'll cover the surface, not just the mating surfaces, but the surface of what I'm welding to help prevent it from burning. It's a little bit of a cheat. So we've got this. And what I'm looking for is the surface to be wet, to look wet, and to be slightly sparking, or almost sparking. Definitely not what you want if you're welding high carbon stuff. I don't want to mess something up there before. So I'm working this bar down to about 7/8 by 1/4 thick, 7/8 wide, 1/4 thick. But obviously, and I hope I don't annoy anybody with this, but I'm not going to measure very much of anything today. But I will just ask me, and I'll be happy to make recommendations on stock size. If I was starting with, I was making a hinge this size from mild steel stock, 1/4 by 3/4, 1/4 by 1, depending on what size you want. This piece of tire. This is a piece of buggy tire, and it's often kind of a half round shape, and that can be annoying. You have to really, when you start to work it down, because the edges are kind of rounded over, that one sharp edge, the piece wants to cut, and that can that can create cracks in the middle. So you really need to be careful starting out until you kind of get it squared up. I know I'm going to get laughed at for my use of coal, but this is just what I'm comfortable with. This is actually the exact same coal I'm using at home, at least I think it is. Travis and Calvin are telling me the batches haven't all been the same. It's coming from a mine out here in Warrior. But I find for me with this coal, for most of the stuff I do, it coats up at about the perfect rate without using any water or anything like that. So I kind of support my fire with the coal, and I'm constantly dragging the coke in without contaminating the fire with green coal. So, I know that's basic to some people, but that's a good heat. I'm not trying to draw out over the horn or anything like that, because not only am I drawing this down to the bar size I want, but I'm also trying to compact it and weld any cracks in the wrought iron that already exist. Personally, I'm really interested in learning how early American ironwork was done and how smiths of that period thought. And one of the things I'm kind of convinced of is that in a day and age when everything was made by hand, or nearly everything, if you think about it, because of that, 250 years ago, there's no romance to things being made by hand. And unless you're some kind of high-end artist or whatever, that nobody's going to pay you extra for something being made by hand. You need to be fast and efficient. And in order to be fast and efficient with a lot of hand work, where am I going with this? You need to not worry so much as most of us nowadays do, about precise measurements and stuff like that. Measurements need to be precise only when they need to be precise. This is kind of my rule anyway. Measurements need to be precise only when really necessary. And otherwise, just get good at eyeballing. And a lot of times you can get really good at eyeballing and train yourself to resize stock or to make things match just by eye. That can be a lot faster with enough practice than fooling with really precise layout. See, there it was cupping on me. Wrought iron tends to crack along the grain, so lengthwise with the bar, which can be really annoying, but I found that a lot of cracks in lengthwise cracks, lateral cracks, you can just work around them. If you can't weld them shut, often you can work around them and they really don't hurt anything. So. If I were working mild steel, I would spend a lot more time hammering and a lot less time heating. but I want this wrought iron really, really hot as I'm doing this resizing. So another thing, and again, I'm just telling you all my pet peeves. I don't expect anybody to agree with me. But another thing I've been trying to train myself to do is to not use the brush. Not necessarily to not ever use it. I still use it a lot. But don't use it where it's not necessary. Don't waste time on it. And part of that is learning to forge in such a way that you're kind of blowing the scale off the piece as you go, knocking it off with the forging. Now I'm really I'm resizing more of this bar than I need, because if you think about it, all I really need to do is resize a few inches for the eye that I'm going to do first. And then I could just draw out the hinge from there regardless of the size of the stock. So y'all bear with me. This is actually only the second demo I've ever done. The first one being nails. All right, so there is our R to start with. That's more than enough for my hinge, but I'm just going to leave it. I'm not going to bother cutting it off until later. It's kind of silly for me to keep straightening it because that's not necessary. But I've gone about 1/4 inch thick. And if you look at that hinge that I passed around, the eye is only about 1/8 of an inch thick. Immediately in front of the eye is about 1/4 inch thick, and then it tapers out from there. And I'm going to accomplish that thinner eye by doing a setting down an area to about 1/8 inch thick and wrapping it up around. But that's not necessary. You can just wrap it around the way it is now. I wanted to bring a couple of different examples of how to do eyes. I just didn't get around to making them up. But basically, you can wrap your eye just whatever parent bar you decide to start with. You can wrap your eye a couple of different ways. You can do an upset corner down and then wrap it around, and that makes a really nice looking eye. But if you forge fast enough and at a hot enough temperature, and you've built up the skill and you're comfortable with it, you can get almost as nice an eye just by looping the piece back on itself, laying the drift in the loop, and then setting that at the right place over the corner of the handle with the drift hanging over, and just going to town on it. But it needs to be a really, really good heat to do that. Thank you, sir. Some water. So a couple things on fire management. A couple more things. When you see me taking the rake and kind of going down around the edges of the fire, I'm trying to accomplish two things. I'm trying to keep the coat broken up a little bit as it forms, because I want to try to keep a compact fire. The other thing I'm trying to accomplish with that is I'm trying to kind of push the coals, the coat, down into the bottom of the fire pot underneath the piece to keep that compacted, because that's where it burns out hollow, and then your fire's neither as efficient, and you're also getting more oxygen to the workpiece, which is not something I want. So anyway, that's what I'm trying to accomplish. I've had people tell me before, oh, you're supposed to always push the piece down, work it down from the top, and that's what they're trying to accomplish, is to keep the fire compacted. I've just never really built that habit. Don't really care for it. But that's what I do. That doesn't mean it's right.
Works for you, right?
Huh?
Works for you.
Works for me so far. All right. So I'm going to lay off, and I'm using a fairly rounded edge handle, a little over 2 inches. Oh. All right, so I've made my set down. It's a little over 1/8 of an inch thick. Set down, and we've probably got maybe 2 1/4 inches there, something like that. And I'll probably go ahead and take just a little bit more, try to shoot for more like 2 1/2. I like a longer scarf. On some forge welds, you want a real blunt scarf so that the toe of the scarf will weld in real good. But for me, on specifically this kind of weld, this wrapping, I just kind of prefer a longer, thinner scarf, and I tend towards a longer, thinner scarf on stuff like this, especially with water. And if I say anything and y'all think you got a better way, sing out and tell me what you think as we're going along. I'm learning too.
I was wondering what the pallet was for.
Those of us that are vertically challenged. Good things come in small packages, Johnny. All right, I'm going to take just a hair more. And I shouldn't be bending over as much as I am, but maybe I didn't need the pallet.
Hey, Jordan?
Yeah.
Those at home, you might want, you can talk about your scarf. You might want to explain real quick what a scarf is. Talk about your
Oh, yeah. Well, you're talking about like what is a scarf? Okay. A scarves come in different forms, as I was saying, but basically, whenever you weld two pieces together, you have to put some thought in. If you want a good clean weld, you have to put some thought into the transition at the end of the piece where it welds into the other. If you were to lay 2 square bars, and I'll tell you who's got a good video on this. If you go on YouTube and look up Mark Asprey Forge Welding Scarf Theory, I think is something like that. His Scarf Theory video. It'll explain it way better than I can with visuals. But yeah, so the scarf is the transition, the end that's going to get welded into something else. And I'll show you'll see that in a minute. Okay, so now we've made our set down. The next step is to make the corner. And I do not want to make the scarf or thin out the end of that piece first. And because it would, having the end blunt will help me when I make this corner. I want to get this corner to a really good high heat corner area. So whenever you're making an upset corner, obviously you can, and lots of people here have done it. You can make an upset corner in the middle of a bar, no problem. But whenever you can, it's always a little easier to make it where you can do a set down first. So that high point right there, I'm calling that the set down. The high point is going to become the outside of my corner. So my corner's already started for me. And it was hot. See if I can do this in one heat. I don't get carried away worrying about how many heats, though. It's more important just to keep things hot enough. So the first thing I'm going to do is I'm going to bend it over. We're going to quench that off. Yeah, this is not cooperating very well. Now, I could continue with this process until I have. See, I'm used to using, one of the things I do when I'm making this sort of upset corner is I'll use the step on my standard London pattern anvil to catch the end of that right there. That kind of helps. But okay, so I could carry on and just make a 90-degree upset corner. But I'm going to go for a slightly different method, I guess, here in a second, which is I'm actually going to go, I'm going to take it past 90 degrees and try to draw that corner out a little bit. And that'll just fill in that, the teardrop, I call it, of the eye a little bit more, which is totally unnecessary. It's just cool, looks good, and it's good for showing off. A hinge eye does not need to be as pretty as some people want it to be to work just fine. Nice and
Square block right there, fits in that hard hole.
yeah. Okay.
Right here in front.
Right here.
If that helps you, it goes one. There you go.
Now I have my corner. Perfect. Thank you, Kelly. Now I could have done this again, like I said, without a set down, but trust me, having that extra material in there will make that inside corner look real nice. That's not exactly what I want. All right, I'm just going to go for it. What I'm going to do here, real blunt hammer blows. Try to kind of draw that toe out. It's always the problem here is that now I can't get to that area there. All right, take a little more heat. I need a real localized heat. I just need the end of that hot. So I'm purposely letting my fire burn a little bit hollow where I can kind of easily get that tip down there into the part of the fire. putting way more work into this than is really necessary, like I said. I want to make it pretty. But we could have already made our eye by now and still had a very serviceable eye. All right, so that's kind of what we've got so far. I just tried to draw that out into a little bit of a sharp edge, and you'll see why here in a minute. Now I'm going to heat the material for the hinge eye itself. If I was real good, I'd be able to make my scarf and wrap the eye in one heat, but I'm not that good. So we're going to partially wrap it and then make our scarf, and then we'll wrap the eye. Like I said, I'm going for a thin scarf. I'm not being too crazy careful with it. If you don't do this, if you don't thin the end out a little bit, a square end, as you forge weld it in, it'll actually kind of cut into the piece that it's being welded into, which will give you a crack, which may or may not be a problem, but it's just a good practice to make a start. So there it is. It's all thinned out. Nothing fancy, but that'll weld in pretty nice. Wrought iron, you want it to be real hot when you're doing any drastic movement. That's the rule. Not all iron is created equal, though. Some of it's a lot more forgiving than other batches. All right, here we're going to go for the bend. Bring that around. I'm gonna clean that off a little bit in there, even though it's probably not necessary. Trying to be kind of slow and easy with that. Take my drift, open that up a little bit. I closed it a little too tight. All right, so now I just very roughly made that eye the size of the drift. I'm gonna clean it up a little bit, and we're gonna take another heat. I'll put the drift back in. So basically, the sequence for me for forming the eye itself is I'll wrap it around. Put the drift in it, clean up any of that cup from bending it. So when you bend metal, it bends more on the outside than the inside of the strap or whatever. So you'll get an eye that's kind of an hourglass shape. That can work. I'm not a fan. So I'll put the drift in there and hammer it until it's a clean barrel. And then I'm going to take the drift out. I use a drift that's really similar in size to my pin, and you kind of got to play with that a little bit because it's kind of a give and take. If you use a drift that is the same, just out of the same material as you make your pin out of. Let's say you're using factory stock 1/2 inch round cold rolled, or for hot rolled, but uses cold rolled. Hot rolled, and you make your pin for the hinge out of the same piece as you make your drift. If you do that, because of the shrinkage of the eye, you're drifting the eye while it's hot, and then it cools and shrinks a little bit. It may be too tight on the pin. But if you're doing a forge welded pintle, that pin may lose just enough diameter from scaling off during the welding heats that it may work out. It's just something you got to play with. If you're making a hinge like with a cut together barrel where it's jointed, and I don't have one to show off, if you're making a jointed hinge where your pin is put in cold and it doesn't go through that forge welding, then you're going to need to use a slightly larger drift. What I would do is I'd play around with it, depending on the style of hinge you're making. And to make your drift, take you a piece of the material that you're making your pin out of to make your drift. And before you taper both ends down like you should, heat it and carefully give it just a couple of licks, not enough to like bend it to spaghetti, but just a couple of licks to upset it. Just like 2 or 3 hammer blows at most, and those are taps. The shorter the drift is, the easier it is to keep it straight in that process. But that upsetting will cause it to grow just ever so slightly. I'd start out with maybe 2 or 3 taps. And then again, make you a test eye, drift it, and fit it to your pintle. I don't know how to, am I explaining that well enough?
Yeah.
And some people, I'm pretty sure the more machinist inclined people in the room, I'm looking at Calvin, would probably, if you really wanted a nice fit on your hinges, make your eye tight and then ream it out with a drill. I don't like doing that because I avoid drilling whenever I possibly can, but that's one way to do it. Huh? There's that too. All right, so now we're going to throw our drift back in here. I'm just going to clean it up a little bit.
At this point, you still haven't used any flux yet, have you?
No, I haven't. So I'll show you one of the most important steps here in a minute. All right, so that's pretty crude looking, but this is what we've got. And I got that eye a little bit thin there at the corner, but I can live with it. So there's what we've got. The end is scarfed. The eye is shaped. You can see the barrel is fairly clean on the outside. I've taken the cupping from bending out of it. And like I said, pulling that corner out there makes a nice looking eye, but it's really not necessary. Anybody over here need a better look? That's what I want it to look like before I start the welding process. Good to meet you. So now I'm going to heat the whole thing up a little bit. I'm going to flux it. And I'm going to open it up a little bit with the flux spoon, flux it. And then as I close it, you're going to see me take a couple of taps. I'm going to hook it over the edge of the anvil and take a couple of taps on the outside of the eye. And what that's going to do is it's going to close it up a little bit, make it too tight for the drift. So that after welding, I can drift it at a screaming hot heat, and it'll actually have some stretching effect on the metal, and the eye will come out nice and clean. That's the theory. Man, that got hot quick. If we burn it, we'll just draw it out and start over. That's the nice thing about wrought iron. It welds so nice. If I slightly booger up an eye, I'll just weld it back into the bar and start the process over without losing very much time or any material. Okay. Let's see if I can get this in there. So now I'm just going to pry that open a little bit. Dump your flux in at an angle so that it coats the surfaces real good. If some is good, more is better. Now I'm going to close that up. Here we go. We're going to tighten the eye just a little bit. Over tighten it. I want the seam. I want these pieces to lay as close as they can, so that I'm not getting dust from the fire in there, sticking to the flux and contaminating my weld. See if I can weld it without burning it. And hinges, I've seen old hinges where the weld was made over a fairly crisp edge on the handle, and I've seen them made over a real rounded edge. So it doesn't really matter. It's all what you like, but there's nothing wrong with doing it over a fairly rounded edge. If you're like me and you're a history nut, you love looking at an antique, something hand forged hundreds of years ago, and seeing, I don't want to see like crudeness, but although that's interesting in itself too, but it's always fun to see the tool marks from the guy that handmade whatever it was. And if you look at that big strap hinge over there on the table, that antique strap hinge, which by the way has one of the prettiest forged welded eyes I've ever seen on a hinge. If you look at it on the inside, where I'm going to lay that eye over the edge, you can see a perfect imprint of the rounded edge of the guy's anvil before we made it. A lot better fire pot than mine. I'm using a really crappy fabricated fire pot that I made 5 years ago, and I had no clue what I was doing. Start close to the eye. With your weld, keeping that tight over the edge of the anvil. If it's not wet, it won't weld. That's not entirely true, but in this case, it's a good rule to live by. So if it doesn't look wet, you're not in good forge welding conditions. So I'll stop. I start out. My first order of business when starting to weld is to drive the flux out of the weld and to get the whole weld stuck. And then I'll go back and finish.
How often should you clean your fire out?
I'm sorry?
How often should you clean the fire out?
I clean it out whenever the clinkers start clogging it up.
Gotcha.
This may, so I totally believe, and I've experienced, there can be weird things happen to your fire that make a weld just not take. I've had a lot more trouble with mild steel with that though than wrought iron. But I do believe that you can have a bad batch of coal or something like that. But right or wrong, I generally ignore most of the sayings about clinker in the fire messing the weld up and stuff like that. And because I believe it can be done, especially with enough practice, it can be done in a lot worse conditions a lot of people lead you to believe. But when you're a beginner and you're just starting to learn forge welding, you should apply a lot of those things anyway to narrow down on and make sure it's not just you. Or make sure it is you, I guess is what I'm trying to say. Make sure your fire's clean, all that stuff. Just so that you don't have anything else to blame the failure on except yourself. Now, once again, this is a personal preference thing. I really don't care on a hinge where the scarf winds up on the back side of the hinge. I really don't care if I see a little bit of it. I want the weld to take. But I mean, if you're a real perfectionist, I'm sure you'll want to, you're shooting for an invisible scarf. But that's not a high priority of mine. I guess if anybody wants a close look at any time, just run up and look. Or Calvin, if at any point you got to pass it around at a certain speed, we'll do that. So I think it's welded pretty good. I'm sort of tempted to take one more heat and just a couple of light blows close to the eye.
Once you get that weld up, like you're happy with it, you know, you're not gonna hold it up.
Okay.
Hammer and get a good look at it. You put a post it on.
And I'm not trying to get this welded area back down to a specific bar stock size. I want the whole hinge to taper in thickness, ideally. That's my preference. But definitely, like even if you look at these antique, and some of them are not forge welded, but if you look at those antique hinges over there, especially that big one, it's obvious the bar size was somewhere around 2 1/4. But right there at the eye, it's more like 3/8 thick or something like that. They leave it thicker in front of the eye, and that's kind of my general practice too. I think it looks good.
George, what do you think about old hinges that have been wrapped real nice but not forge welded?
It all depends on the application. I like forge welded hinges mainly because I'm a show off, but for a lot of applications, it's totally unnecessary. And if you're dealing with a lighter application like a cabinet door or a shutter or something like that, it's just not necessary.
Do you see an association with that and purely application or time period? I know they got some out of the ground at Jamestown that were wrapped that were not forge welded.
Yeah, I'm not an expert on that, but it's my impression. It's my impression that it's more application and preference, and it's not time period. Now, obviously, at some point, forge welding goes out, nobody bothers anymore, and hinges are all just wrapped. But in way back, it's more of a style and personal preference and application thing. I have never seen a 200-year-old barn door hinge that didn't have a forge welded eye. That's a high stress application. But I've seen like some house door hinges that had a wrapped eye, and I've seen cabinet hinges and stuff like that. So generally the idea is you can get away with a smaller, and this is my opinion, you can get away with a smaller, lighter hinge if it has a forge welded eye. It'll be stronger for the size. I took that eye down, I kind of got it a little bit hot. We burned it a little bit, but I took that eye down, the thickness of this eye down to like 1/8 of an inch, whereas my strap's going to taper from, 1/4 inch on down. If that was a wrapped eye instead of a forged welded eye, I would leave it full thickness for strength. In another aspect, and this is just in my opinion again, but while a welded eye might be a lot more time consuming, personally, I hate making wrapped eyes. They're a pain in the rear. For me, it's easier to weld it and leave it a little tight, run that drift through it, and it's good to go. Because it's welded, if it welded nicely, it resists the drift. It stretches out. But if it's a wrapped eye, then it may open the eye back up, but without you getting a good bearing surface inside, if that makes sense. So. All right, here we are. So we're welded together. Hopefully it'll be a little tight on the drift, so the drift will open it up. I got it a little crispy, burned it off a little bit. Yeah, there we go. Is that good?
Come closer a little bit more.
Okay.
That's
Kick the
good.
camera.
Now rotate it. Just so people can see everything. Go around 360 with it.
Pirouette.
So there we go. And you can just barely see the end of the scarf there. Anybody want to look? It'll look nicer once we get it drifted. Just the hair. They were all welded up. And this is more theory than practice for me, but I try, whenever I can, whenever I'm forging something, I try to work, like a hinge is a good example, I try to work from one end to the other and finish the piece as I go, instead of going back over it lots of times, back over the whole piece lots of times for different things. But it's not always convenient, and one of the things is I like to leave touch marking for the last so that it doesn't scale up. My touch mark doesn't scale up. So now comes the moment of truth, because purposely made that eye a little bit tight. And when I run my drift in there, we're going to see how good it welded. If it didn't weld perfectly, or if it didn't weld good enough, then we'll get a crack. And frankly, for me, depending on how bad that crack is, if I'm making hinges for somebody else, then that might be a problem. I might want to try to weld it up better, go back in the fire or whatever. But a little bit of crack, a lot of times, is just not a real problem. So, all right, so we're gonna throw the drift in there. And I think it welded pretty darn good. I'm happy with that. It didn't crack at all.
What would be a typical application for a hinge this size?
Shutters, window shutters, a cabinet, a small door. This, even though, I'm kind of like probably the rest of you. If I'm going to make forged hinges on a door, I want to show off and, make something impressive. But it wouldn't be unheard of for like a closet door in a period house to have a hinge this small. Although it'd be more typical Chris, you might know more about this than me. It might be more typical in the colonial period to have like HL hinges on a interior house door than a strap hinge, but you do see the strap hinges too. So.
And areas, German areas, you tend to see a lot more strap hinges and a lot more a lot more flowered, scrolled out strap hinges. And sometimes I see some I've got one old one that's like engraved, but it doesn't have a welded eye. It's just wrapped around, and it's just mind-boggling.
Yeah.
Yeah.
Okay, so in the spirit of working from one end to the other, I probably could have waited to do that drifting step until the next heat or two. But what I'm going to do is I'm going to punch my first attachment hole, which in some cases you need to know certain things about the door it's going on to know where to put the holes. I'm making this just to match some other hinges I've already made, so I kind of know the hole spacing. Once again, I'm not going to bother laying these holes out with a center punch or a ruler or anything else. I'm just going to eyeball it, which is perfectly acceptable if it works, if it works for the application. I'm going to punch my first attachment hole and bevel the edges, and just for the first couple inches after that eye. And also my touch mark goes there. I don't know if I can get all this done in one heat, or it'll probably take me more than one. There's my punch. I'm punching like 1/4 inch holes. They're kind of big for a hinge this size, but it's because the nails that I would use to attach it need a hole about that size. Let's see. I thought about picking that drift up barehanded, and then I thought better. Just never a good idea. All right, let's see. What do I want to do first? I'm going to punch. So this is something that catches me all the time, but I prefer to finish punching from the back side of the strap so I don't mar the top of it. So you just need to create a rule in your head that you always start punching from the side that you want down. So I'm going to start punching from the back side of the strap. It's not the cleanest punching job in the world. I think I got enough heat left to touch mark here. When I'm beveling a piece, I always bevel the side away from me first, because I find that it's harder to do that side. And so I've got more heat starting out. And so do the hardest first, and it'll usually work out better. So I'm going to throw the drift back in at a somewhat low heat. Man, that eye is tight. And I'm going to make sure that the eye right now sits tight to the anvil face. Basically, I'm just trying to make sure it's the tendency for the eye to kind of lift up from the plane of the back of the hinge. And that's what I'm trying to make sure is not happening. It looks pretty good. It's been my practice to leave all the tweaking for the last, and I'm trying to get out of that habit. I'm trying to do as much of it as I can as I go, finish the hinge, finish one section before I move on. Now, Calvin, do we have any tongues that would reach around that eye and hold the strap? Yeah, something like that. See what this feel like. Perfect. That's perfect. If I can get used to them. Good, my shovel. That's okay. This is fine. So one of the hardest parts of making a strap hinge like this for me is guesstimating the amount of material. But that's the way I prefer to do it, is guesstimating. I'm trying to train myself to be good at estimating how much material. It's fairly easy to make the first one and then make more to match it. But when doing especially like a big strap hinge where it's not only is it tapered, it's tapered on both axes, and that can be interesting to estimate the material, especially when it's not usually an even taper. And
Have you learned the dimensions of your ankle where you use your ankle a lot?
Yeah. Like I know my face is about 4 inches. I don't know exactly how long. My hammer is about 1.5 inches square. I'm using the edge of the hammer face as kind of a fuller to more rapidly draw out the material. So I'm canting it a little bit that way. And I'm doing that from the back side. So if I leave any marks, they're on the back side. On a strap hinge, I like a pretty significant bevel on the edges. And so it's always a good idea to make the initial strap before beveling look just slightly skinny, because when skinnier than you want it to, because when you bevel it, it'll widen it out just a little bit. So I'm going to get that hinge. And I'm gonna try to make this one about the same length. I learned the hard way on this pair of hinges I made the other day. I left myself way too much material for the penny end. If you want a real small penny end, for some finials, when you neck in right here, you need to leave yourself more material on the end. But for a small penny end like that, I would not leave any extra material at all. You may catch that when we get to it. Less talking, more working. Trying to sneak up on it. Go faster and mess something up.
You always use that 50 already.
Huh?
You always use that 50.
The speed right now is not the problem. You know, doing something this small on a wrought iron, it's so easy to forge. I'm just trying to be careful. Okay, that's plenty. I may still cut some more off. If you're used to using, that was probably not a good idea. If you're used to cutting mild steel, wrought iron will really surprise you because it's really easy to cut. And it also tends to kind of break and your cutter go through it. And it'll surprise you. In other words, it's real easy to hit your hot cut. I'm not going to get too crazy about the thickness, but I am always very impressed when I see a hinge that's tapered nice and even in thickness. I do find it's more common, though, to do that on larger hinges than on small hinges. At least that's been my observation. And it's liking that pretty good. So now, because I don't have normally if I was making a penny end or round end, and if I necked down behind, made a neck before setting down and spreading the finial, I'd knock the corners off before spreading it out. But since I want a small penny end, and I don't have that neck to start with, and I don't have that luxury, So I'm gonna set down, I'm gonna take about a square of material. I really like cross beam work, but for some things it's just not necessary. It's such a small thing. All right, now we're going to round it up a little bit. All right. Remember what I said about not always working from one end to the other like I ought to?
Jordan, why do you set that penny end down? To spread it?
Well, you certainly don't have to. But, and I've seen hinges done both ways. Ooh, that's kind of ugly. But I like to. If you look at, it's real common on old ones. So let's see. This one does. This is kind of rusty, but that one doesn't really have to set down. It's not there. Neither does this one. That one's not set down either. And it looks good, but it is very common to set them down. This one's got to set down, and this one's. You can see it set down. It's a lot. It's kind of easier to do. Sometimes if you're doing a finial that requires cross beam work and requires some more material movement. But this one here, that was obviously made with a cross beam and it wasn't. They didn't do it. I don't like that, so I'm gonna do a little bit more to it. I should have easily done that in one heat. I can live with that. All right, so now we're going to punch holes and bevel edges. So on a lot of larger strap hinges, well, a lot of strap hinges in general, it's very common. This one doesn't have it. This has just got 3 fairly equally spaced holes. So does this one. This one's got 3 holes fairly close together and one on the end. But it is real common for teams to have the first 2 attachment holes close together, 1 hole in the end, and then 1 or 2 more kind of equidistant in between. And it's also really common on old strap hinges for the first 2 holes that are set close together to be countersunk and actually riveted to the door. So a rivet is made with a large head to go on the inside of the door. It's put through the door and cold beamed into place to lock it in. So those first 2 holes are countersunk. And actually, this one here, it looks like all the holes. This one, this large hinge is more apparent. The first 2 holes are countersunk for the rivets, and then the other holes they didn't countersink them because they just put a nail in them. And the nail may or may not have been clinched over on the inside of the door.
Is there a reason for that? Is it for weight of the door, or
just the practice of riveting the first 2 holes is it's never coming apart. I mean that handles. That's where most of the strength of the hinge is right there. And if the hinge is going to try to come away from the door, it's going to do it close to the pin, close to the eye.
This seems to work with
My general thought is I like to put that first hole as close to the edge of the door, as close to the eye as I can get it. But that all depends on the design. Do it on time. 10:35. Well, it's not as bad as I thought. I've been at it about an hour. All right, so I'm gonna go for my second hole. I'm gonna put my first hole is about 2 inches total from the eye end of the hinge. Oh, see, I did it wrong. I started from the side I didn't want to. That's okay. Now let's see if I can get this other hole. And did it again too. Wrong songs. Better to do this at a higher heat. But I think I got just enough heat to do it. I like to make several passes when I'm beveling. One pass, and it's usually better to start at a higher heat, but one pass is to kind of establish, do the bulk of the bevel, especially if I'm doing a fairly severe bevel. And then, because it's easier to do a major bevel at a higher heat, and then I'll go back over it and clean up the hammer marks, because I personally don't like stuff to look really, really beat up. I don't mind some undulation, I don't mind some hammer marks, but not too much. Somebody told me forging is fast, tweaking is forever. Now, usually anything that's less than 1/8 of an inch thick, I'll cold punch. I don't like fooling with hot punching something that thin unless I have to. That's not too awful bad. I got some major scale in this one area, so I'm going to go ahead and heat it up again. If I'd been good enough at that, I'd have pulled that scale off with the hammer. Now this hinge came out with a little bit more even taper than this one. I'm just going to leave it like that. Looks fine. I'm more concerned about sets of hinges looking alike. But it would be a very, very simple thing to spread that hinge a little bit more in the middle to give it more of that curving, uneven taper. Something I didn't mention that I think is kind of cool is there are there's almost as many styles of strap hinge historically as there are hinges. Lots and lots and lots of variation. And you'll see some that flare out in one form or another, directly past the eye. The strap flares out. And one way you can accomplish that, watch me burn the hinge right there at the last, that would be awful. One way you can accomplish that is by using the material from the scarf. So if I wanted a good flare for the first, let's say, 3 inches of the hinge, I'd leave a fairly thick scarf. I wouldn't thin it down a lot, except right at the end, and I'd lay it over there, and that would give me, during welding, that would give me the extra material. And I would probably, if I wanted that really wide, I'd actually use the cross peen during welding to spread it out and create a real drastic flare. And that's a way to get some really major, change in your piece without really any extra work or very little extra work. Whereas, this is what I'm talking about. Now this is not a wrapped and welded hinge, so the analogy only goes so far. But this flare right here is what I'm talking about, or something similar. Sometimes you even see them with a big disc spread out right there. And like I said, you can do that simply by giving yourself more material with the scarf of the hinge and spreading it out as you weld it. And then that gives you a more, a really serious change in dimension. That would be a lot more work to draw out of a larger piece. And that's one thing I feel really strongly about is learning to forge weld and forge weld fairly reliably. I must actually burn that a little bit there. It opens up so many possibilities, and it actually forge welding makes a lot of things easier to do than if you tried to accomplish the same result without welding. And so a lot of rookies I hope I'm not stepping on any toes here. This is just my opinion. I have been around a lot of smiths that are just like, well, I'd rather do it this way to avoid the forge welding. And to me, that kind of, I like the traditional side of blacksmithing so much that just kills it for me anyway. But what I'm trying to say is practically, it can make things a lot easier just to do the forge weld. But you have to be willing to put the time into actually getting decent at forge welding. It's not that hard. Good enough for who it's for.
I noticed you have very strong feelings, Jordan.
Yes, many opinions. Johnny noticed that a long time ago. All right, so that's all I'm going to do on that until it cools, and we'll cold punch the end. Probably cool enough. I don't like to quench things off. If you quench things off at too high a heat, you'll pop the scale off and give it a nasty look. So cold punching, something I really enjoy, but yes, I have hit my hand, and that's not enjoyable. So basically what I do is I make up a hardened punch with a flat end, and I make a bolster. I forge a bolster that has a hole in it that's pretty close to the size of the punch, but the punch is a little bit loose. This one's actually a little bit tight. But the punch fits the hole in the bolster. The hole in the bolster is drifted from the bottom so that it's tapers out, and that way your slug that you shear through doesn't get caught in the hole. And I just do that out of mild steel. This is a disposable item to me. And when they get, it's funny, when they get more worn, the more worn the bolster is, because you'll miss a little bit and you'll catch the edge of the hole and whatever and start to eat it out. When they get more worn, the more worn they get, the bigger the hole is compared to the punch, the more rag you'll get around the edge of the hole. But I want that sometimes. On some of the smaller, lighter hardware I make, I'll actually intentionally use a looser bolster so that I have a rag, and I'll punch from the face of the piece, flip it over, and beat the rag back in, and that gives me a naturally countersunk hole. And I'll size those things, my punch and bolster, according to the size of bevel of traditional flat straight slot screw that I'm going to use, so that it'll fit in there pretty decently. And that way I've got a countersunk hole, no drill press involved, no need for a countersink bit or anything like that. Not that I'm above using those things, but if I don't have to, I don't want to. So what I'll do is, yeah, yeah. So if I want a rag, I call it the suck around the hole. You just need to punch from the. If you want a countersink, slide countersink, and even if you want to go back and use a countersink bit to clean it up, just punch from the side that you want the hole to be larger on. If that makes sense. So what I'm going to do is I'm going to place the punch where I want the hole, and I'm going to stare at it. And then I'm going to stare at the hole, and I'm going to move them back and forth until stare at the hole and move the punch back and forth over it a couple times till I feel like they're lined up reasonably well. And then I'm going to hit my hand. There's the hole. When you get good at that, it's faster than going to the drill press, in my opinion. Sheared out a nice, and I used a tight-fitting bolster this time because I need my hole to be fairly large for the nails that I'm going to give to whoever gets the hinge.
Depends on how long you got to stare at the hole.
That's right.
You have to stare at that all day.
Longer you stare at the hole, the less chance you got of missing it. So. All right, so before we move on to the pintle, any more questions or comments or criticisms?
I'm trying to spread those out a little bit, Jordan, so we don't run out.
I thought you had an inexhaustible supply.
I want to know, he come out of Tennessee, I want to know what's in the canteen.
I know, right? When I'm in the shop, I'm always drinking out of a mason jar, but you can imagine the kind of comments I get online about that. Anybody want to see it? Huh?
Just Tennessee water.
Right.
Yeah, we'll pass it around.
I can tell you right now, it ain't perfect. There's things I don't like about it. But that was a heck of a lot faster than the first one of them I made the other day. Yeah. Oh, that's another pet peeve of mine. I got a lot of pet peeves, as Johnny can tell you. A lot of us, me included, almost nobody likes repetition, making the same thing over and over again. But I personally, especially since I'm trying to do everything by hand and develop skill with a hand, hand skill with a hammer, I believe strongly that it is. I've learned to try to embrace repetition because repetition is an extremely good teacher. You make a strap hinge, and then you make another one like it 2 weeks later, 2 months later. You're not going to learn near as much as if you went straight from that one strap hinge into another. And if you made 100 of them in a row, you did nothing but, you're gonna learn things that you would never learn spreading that 100 out over a year or 10 years.
Personal habit, when I light a fire,
Mm-hmm.
I'll throw a piece of just scrap steel, and get out some small rod and start playing nails. The fire gets up. Just warm it up to hand can.
Yep.
That piece I threw in there, I pull off, cut it in half, and do 40 bucks. Practice.
That's a great idea. Nails are kind of something that are near and dear to my heart. I've made a lot of nails. I enjoy making nails because I've embraced the repetition. And I've been able to see over the course of the last 5 years, my nail making skills improve and continue to improve. Just because I make a boatload of them, not as much as some people do. And I'll kind of contend that it takes me probably to feel like I've really gotten into the swing of it, no pun intended, 50 to 100 nails to get really warmed up before I feel like I'm actually starting to get into the groove, you know. All right, so where's that pencil at? Is it over here? There's a lot of different ways to make these, and there's a lot of different styles, even with just a simple drive pencil. Let me show off this other one. For a light hinge and a light application like a shutter, there's not a thing wrong with making a pintle like that. That's just got a 90-degree bend. But I generally prefer, and that doesn't even require a forge weld. If you're working with a wrought iron, and even in mild steel, you need to be careful with your corner, not to develop a crack, stress crack. But I like these. I like the forge welded pintle myself. Wrought iron has, for anybody that hadn't worked with it, wrought iron has grain like wood. It has real fibrous grain. And it's, in some ways, it's more fun for me to work with than mild steel. But almost everything short of maybe forge welding, mild steel is more forgiving. It's more forgiving and maybe more fun for a lot of folks. But this design accounts for the weakness in wrought iron, which is its grain. It's also its strength. But because when you make it like this, the grain in that pin is oriented up and down. I mean, it is with this too, but it doesn't have to make a corner. So anyway, this is really strong. There's 2 forge welds in this, in a sense, but they're done at the same time. The pin is forge welded into the body of the pencil, and the body is wrapped around the pin and welded to itself and drawn out. So I'm starting, and that's a little itty bitty pencil. But for this little itty bitty pencil, I'm starting with this piece of stock that I've drawn out. It's about 3/8 by half. It's about 3/8 thick by half wide. And the wider dimension, it's going to be laying flat on the anvil as I make this. Well, in orientation. So the wider dimension, it's actually going to be wrapped around that pin with the half this way, horizontal, and you'll see why. Let's see. Don't know if I brought my 1/2 inch. Some 1/2 inch tongs. Okay. Man, I like them little bitty light tongs. Perfect. I think. So I'm starting with a blunt scarf on the end of my bar. And I use a single bevel hot cut Hardy a lot. Don't use it all the time. I actually currently don't have a double bevel, and I should. But the single bevel is real handy for all kinds of things. And some of the reasons that I like the single bevel, a double bevel will work if you're careful with it. But one of the things this is real nice for is when you want to leave a slope on the end of a piece, but you want to if you want a really nice straight cut on the end of another piece. In this case, it works out perfect because that slope is my scarf. I don't have to do anything else to that. It's already made my scarf from where I cut the last piece off. And so we'll see that in a minute. Just be looking for it. Yeah, I like those better. So once again, there's like with the eye of the hinge, there's different ways to do this. I could loop this bar around without doing anything else to it. Just bend it in a loop, weld it around the pin, no problem. But I find it works a little easier for me to set down an area, kind of like when you're doing a wrapped and welded axe eye. And I'll show you what I'm talking about. So again, my bar is about 3/8 thick and kind of a shy 1/2 inch wide. And for this first step, I'm going to be standing that 1/2 inch up on the handle. Scarf is standing up. I'm going to go over the anvil only about 1 inch, and I'm going to set down to about 3/8 squares. I'm only going in about 1/8 of an inch or so. Then I'm going to come back to the other end of the anvil and come back. All right, kind of a double set down. I'm going to deepen the first one a little bit. And you can see I'm dressing thickness as I go. See that? Now I'm going to take that lump out of the middle with the pin of the hammer. Now this is something kind of trial and error. You may have to play with it a few times to get to figure out what the right length is for the diameter of pin you're using. That's a fat inch. It's a little over 1 inch. I think that'll do. If it's a little tight, it won't be a problem. But I do want, when I wrap it around, I want that hole to be too small for the pin, but not too small. So you want this, whenever you're welding a pin into, or welding a piece into another. Another example of this concept I'm trying to get at here is a collar weld. So the knob on the end of this is a collar weld. And that's where I've made a collar material and wrapped it around the bar and forge welded it on. And you want that to be, you want it to be too tight, so the ends of the collar are spread a little bit when you put it on there, and that way you get you got plenty of squish for forge welding it down onto the pin. Same concept here. Ooh, that's toasty. All right, so now we're going to bend that around. That's real toasty. And there we got our hole. It's a little bit, where's my drift?
On the floor.
There's a lot of floor. Okay. All right, so now we're going to send this drift back through here. No, maybe we're going to try. Same drift. And I'm not going to worry about cleaning that up anymore. But I am going to tighten it just a hair. Now I'm going to take my pin. That's my lunchtime alarm, y'all. Now I'm going to take my pin. I tighten, just same concept of like tightening the eye on the hinge before drifting. I tightened that eye up a little bit after drifting so that when I put my pin in, it'll be a tight fit. And it won't fall out. Like that. Went straight on through. Maybe we'll try it from the other direction. Nope. Watch me fumble a few more times. We'll just lay it flat on the anvil and see if that works. And the pin, the top of the pin has a taper. Short taper. And you can see that here. A little bit of a taper, maybe a 1/4 inch, 3/8 inch long on top of the pin. And that helps with putting the pin into this for welding, but it also helps when you have actually put the hinges on the door that you're installing and you want to take the door off or put it back on the hinges. That little taper helps a lot. Another thing I like to do, and this is just personal preference, I don't know if anybody else does it. I like, if I'm making a pair of hinges, if I'm putting 2 hinges on a door and I'm making a pair of hinges, I like to consciously make the pintles different heights, like a 1/4 inch difference or something like that. And that, so that if, gate or door, if you are going to hang the door, if you've had the door off and you're going to hang it, then you can, you only have to worry about getting one of the eyes and pintles lined up at a time. You get it on the longer one, and then you line up the shorter one and it slides on. If they're exactly the same length, it's a heck of a lot more trouble to put it together. Very, very, very common. But the pin is almost always sticking out the top of the eye on a hinge like this. And sometimes it's an awful lot on old ones. I usually just stick the taper, it's however long the taper is, that's how much extra length I've got on the pin. I also will leave when I drive, you may have noticed when I put the pin in for welding, I leave it sticking up. I leave the butt end of the pin sticking up. 1/8 of an inch, 1/4 of an inch, depends on the size of the pintle I'm making. And I'll weld around it, and then I'll turn it up, and you'll see me weld that butt end of the pin down, and that mushrooms it out, kind of fills the weld in a little better. But you got to get the first weld done good, or the pin will just push through. All right, so we're going for flux again. I could probably weld it just as is. Tempted to. I'm going to put flux on that pin to help prevent it from scaling. I don't know if that's actually how it works, but it makes sense to me. So I think it helps minimize the amount of material you lose to scale. All right, so I'm going to take it to a welding heat. I'm going to go kind of slow, and I'm just going to keep that pin sticking up in the fire so that it isn't as likely to burn. You can make these with just a round section underneath, and I think there's one over there on the table like that. But a lot of them are square like that, kind of diamond shaped. That's a lot easier to weld because you're welding it that way instead of having to try to weld all around this thing that you can't really get on the other side. It can't really support and whatever. So the diamond shape's easier to make. I need to get this welded in further. It really wasn't as hot as it should have been. Now, if you wanted to cheat, this is an area where you could use a guillotine tool to butcher in from each side, and then add a welding heat. But I'm just gonna do it by eye. But if you notice here, look at this one. I'm trying to hang this over the edge of the anvil like that, and I've got to use my hammer in there to bring that down to size.
We'll just call that a different technique. We won't call it cheating.
That's right. There are no cheats in blacksmithing, really, as long as you're honest about it.
I'm a big fan of it.
Oh, I cheat all the time. Different technique.
Not cheating, it's working.
Woo! Okay, that's one.
That's good weld.
I need my bolster. Okay, so bolsters. You can do this without a bolster. It is possible, especially if you have a decent Pritchell hole. You can kind of work it around the hole as you're going, and you don't technically need the bolster. But a bolster with the proper size hole in it that's drilled good and square, I did use a drill press, helps a lot. Different technique.
That's right.
Of course, it was one of the hand crank drill presses, right?
It wasn't, but anyway. I got that pretty crispy. You know what? I'm gonna get crispy too. I'm gonna throw a little more flux on there just for the heck of it. Again, this is the flux at this point. It's not helping the weld. It's just helping me get it hotter without burning it so much.
So you really gotta keep that wrought iron white.
Yeah. Welding heat. Depends on what you're doing to it too. At this point, I'm not really worried about it because I'm not doing anything that would cause it to delaminate. But I think I'm going to go, before I use the bolster, I'm going to go ahead and do my squaring up. Again, at a welding heat. Now that pin's probably welded itself in there pretty decent. But the idea right now is not only to get that square shape, but to weld the pin. So I've drawn that in the middle down. A little bit at a time each side. Now into the bolster. I should have heated that up more back to wet heat, but it's all right. That was coming out a little bit lopsided. Must have burned some material off that one side.
Now, when you get that to the forge welding temperature, do you find that wrought iron loses a little more material than just mild steel?
I don't know. I haven't really thought about it much. Definitely loses material when I get it too hot and burn it. It's more forgiving than mild steel as far as burning goes. A lot of times, if it's burnt a little bit, you can flux it and kind of weld it back together. My mild steel just doesn't like that as much, seems to me. Oh yeah, scorched the middle of the pin a little bit. Still functional, but it's annoying. All right, now I'm gonna go ahead and cut it off. See, this is what I'm talking about. With this single bevel hot cut, now my bar is scarfed for the next one. And it would still do the same thing with a double bevel, but if you want a fairly clean end on whatever you cut off, then you don't need much material to draw out the spike. So these tongs right here is a little bitty pair of sort of flimsy old tongs that I found somewhere. And sort of like a pair of chain tongs, I've made one jaw been around like a fit, just barely catch over a piece of like 5/16 rod. And I find those super handy for all kinds of stuff. I made those for holding the barrel of a really tiny cabinet hinge while forge welding it on the handle. But it comes in handy for all kinds of other stuff too. Grabbing small pins where you need to stay out of the way of the rest of the piece. This is making me realize just how horrible my fire pot is at home. Here we go. So you want to be careful as you finish up to make sure the pin is square to the body, which obviously right now it is not. Is there a sharp cold chisel in here somewhere?
Yeah.
Keyword being somewhere.
I like it.
So, depending on the wrought iron you have or the mild steel, man, that is horrible looking. How much black heat tweaking you can get away with really depends on the material you have. It's something you want to be really careful with, both in mild steel and wrought iron, because you can make cracks. But well, it's enough to get the point across, I guess.
What do you do? I don't know where it is.
But the main thing is, even as bad as this looks, you see how offset the pin is, the spike's a little bit offset and whatnot. Those are aesthetic issues only. It doesn't matter. But what's important is that the pin is square this way and this way to the bearing surface. As long as you got that, you're all right. And Chris, where is Chris?
Right here.
You may know more about how these things are installed than me. Is it common?
Lose that bet.
Is it common practice? If you don't know, you don't know. Is it common practice to have the strap, mount the strap on the door, and then have the pin inserted in the strap while you drive the pin in?
I've done it the other way, where I'll put I'll wedge the door up, wedge the door up where it needs to be with little wooden shims, put it right where it needs to be, mark the pintle, drive the pintle in, and based on where the pintle is, I'll hang the hinge and then mark on the door that's hung there, right where I want it to be, where it needs to receive either the nails for clenching or bolts or screws or whatever.
Yeah.
I kind of do it. I'm not.
That's kind of what I lean towards, but
Yeah.
one of the
I know that
things
works. I know that works for me. Somebody else may have a better idea of
Right.
how to do it. And
one of the things I do think helps though is especially if you have a long strap, once you've drilled your hole, you've decided where your hinge is going to go, and you've drilled your hole in the door frame to accommodate the pintle. Then height's not an issue. You just put the pintles in. But even when installing the pintle first, which is I think that's the right way to do it. That's the way I do it when I do it. You can put the strap on the pintle and hold it at 90 degrees as if the door was there, and that keeps the pintle, from turning sideways while you're driving the pintle in.
Yeah, and I made myself I forged out a shim and got it real hot. I actually drilled a pilot hole, and then I made a tapered rod about the same, a little smaller than the pintle, and I just put it up
Right.
yellow and just burned it in. And then I got a little water can and put out that fire because it'll keep burning.
Yeah, and I think that's called a burning hole.
Yeah.
I do it too.
That
So
works really well.
make you forge the end of a bar to the same taper as that. But you need to. A couple of things with that I found are really important. Is the bar when you're burning it, it needs to have color. It doesn't need to be at a black heat. The hotter it is, the cleaner the hole you get, and the less charring out from the hole. You need to do it quick and hot. And
And have your water bottle.
Have your water bottle.
Nozzle, you can stop that burn right where you need it.
And I don't remember what else. But
Now, do you ever bar pedals?
yeah, the one that I made, and that's what I was asking for the cold chisel for. It's kind of a pain to do hot. I'm sure it can be done, and I did that one hot. I think it'd be easier to do with a cold chisel, but you need a sharp cold chisel and one that's properly hardened. I don't think I brought a cold chisel. So the barbing needs to be put in. Try it. Let's see. This is the part I'm not really sure about. Had a wedge to lay under it for support, lay under the spike. I don't know if it would work good. Am I thinking about this right?
Yeah.
Yeah. I saw somebody do this, put the barbs in backwards, and ever since seeing them do that, I've been scared I'd do it myself.
And you're looking at old hinges, Jordan. How many? What's the ratio of pintles that are barbed and ones that are not?
I don't know. It seems of the few that I've gotten my hands on, they're all barbed.
Oh yeah.
But that's not really. I'm afraid my cold chisel's not really good and hard. And they're all barbed on just 2 opposing corners. They're not barbed on all 4 corners.
The barbs are set at the same spacing on each side, or they staggered?
Totally random. And I'm not gonna get real crazy about it on this one. Burn the pin a little bit. If it was going to a customer, I'd probably make them a new one. But if I was using it myself, it'd probably work fine.
When you made that on the back.
I have had problems before. If you burn it a little bit, you may have some fit issues with some of the metal slumping a little bit. In which case, a file will fix you right up. Having that end square is also really nice when it comes time to hit it with a file. There we go. It ain't as pretty as the one that I was able to fool around with. I don't know why I'm holding the fire together, but out of habit. Now, my tendency is to draw those pinholes out, draw the spike out kind of thin and long, because I'm thinking about possibly clenching it on the back side of the door frame, which is not always done. It depends on how thick the door frame is. But
Did you clench them in your house?
I haven't put any in my house. You know what they say about the cobbler's children? Have no shoes. I ain't got any. I can't say I've got some hand forged stuff in my house, but I have literally no doors mounted with hand forged hardware in my house yet. But they're all going to be eventually. I got my back door right now. My back door's an old antique with the glass busted out and plywood over it, and I got the new door sitting on the front porch, just waiting for me to make the hardware.
All right, that's a good job.
Good job, yeah.
Well, thanks for having me.
You're doing a great job. We thank you for driving down, doing the demo today. We're gonna have a iron in the hat now. If anybody's bought the tickets, we'll go back here. I think everybody knows how the iron in the hat works. When they draw your number, you get to go to the table and pick out one item. And I think we're gonna set up to do that right now. And we'll what, John?
And pass.
Yeah.
Anybody needs tickets, come see me real quick.
Me too.
Y'all get your time?
Most of the time. If I